This topic is about differential equations, and if you go to college and study math, you can actually take an entire course in this. So first of all, what is a differential equation? Well, it's just an equation that has derivatives in it. So for example, here you can see y double prime plus 2y prime equals 3y. And as just a reminder, this represents the second derivative, and this here represents the first derivative. So it's kind of an exciting time in your math career where you solve a new type of equation. We of course could rewrite that top equation as f double prime of x plus 2f prime of x equals 3f of x. So that shouldn't look too different, it's just different notation. But we can also write it like this. As a reminder, we put this 2 here to indicate it's the second derivative. And we're very familiar with this dy dx. And for the most part, we'll see our differential equations looking like that. So the solution to a differential equation is a function, or it could be multiple functions. For example, in the problem above, a solution would be f of x equals e to the x. Now let's show that that's true. So it doesn't matter which notation that we use, and so we know that the first thing that we do is we take the derivative twice. So f prime of x is obviously e to the x, and f double prime of x, take the derivative of this function, and that's also e to the x. So my second derivative is e to the x, and then I'm going to have plus, and then I'm going to write a 2. And now I'm going to take my first derivative. Well, my first derivative was right here, was also e to the x equals 3, and my y value in this case, or my f of x, is just the original e to the x. Now I could put a 1 here if you'd like, but we're basically saying 1 e to the x plus 2 e to the x, well that's 3 e to the x, is in fact equal to 3 e to the x. So you can see that that was a solution to the equation, which is a differential equation. All right, so we're going to go ahead and we're going to solve these now. And we're about to do something that you might feel nervous about or say, this seems strange that we can do this, but go ahead and trust me that this is the case. What we're going to do is we're going to go ahead and multiply by dx on both sides. And that's the thing you're like, Sorensen, that seems weird. And we have a dx in the numerator, which cancels with our dx in the denominator. So I'm simply left with dy, and if you want, you could write a 1 there, and then I'm left with a 2x plus 2 dx. So our goal is to solve for the equation that satisfies this, so I'm going to go ahead and integrate both sides. So I'm integrating this. So that's going to give me the integral of 1 dy. Well, this means it's respect to y, so I've got to answer in the variable y. And then I integrate the following here. Well, that's going to be an x squared, because now we're talking about taking the integral with respect to x, and then plus 2x. And don't forget your plus c. All right, now on the second one here, we want to rewrite the f prime of x as a dy dx. And again, our first step after that is going to be to multiply by dx on both sides. Okay, my dx is canceled, so I'm left with a 1 dy is equal to negative 2x plus 1 dx. Integrate both sides, I get a y, and technically I get a plus c here, and I'll talk about that in a second. And here I'm going to get a negative x squared plus x, because again, we're in terms of x there. And there's also a plus c here. And so before I just wrote a plus c here, and that was kind of oversimplifying it. But you can think of this as a c1, and this is a c2. Then you could subtract c1 from both sides. This would disappear, and you're left with y equals negative x squared plus x, and then you can say that some c2 minus some c1 is still some c value. So you don't need this inner step right here. I just wanted to clarify why I could simply put a plus c here at the end. So there I am. I've got my answer. All right, let's just see if we can make this a little bit harder here. So if I am going to multiply by dx here, I'm left with a dy, or a 1 dy is equal to a negative, and I'm going to go ahead and bring this up as x to the negative 2 dx. So all I've done is just bring that positive exponent up into the numerator. I know that's going to be easier to integrate. So now I integrate both sides. This gives me a y, and then this is going to be a negative x to the negative 1, because I added 1 to that. And now I have to divide by that same number, plus c. Well, my negatives are going to cancel, and then I'm just going to be left with y equals 1 over x, because I brought this x downstairs, if you will, plus c. All right. This next one here, again, I multiply by dx on both sides. Okay, and this cancels. I'm left with a dy is equal to 1 over x plus 3 quantity squared dx. Okay, now this is going to be a u substitution problem on the right, but let's go ahead and integrate here. I'm going to integrate 1 dy and I get a y. Now over here, if I let my u equal x plus 3, okay, my du is going to be equal to 1. So this is simply going to give me 1 over u squared, which I can rewrite as u to the negative 2. And then this is going to be a dx, or I guess a du, excuse me, because the 1 dx right here is a match. All right, now integrating that, I get y equals u to the negative 1 over negative 1 plus c. Okay, I can go ahead and rewrite this right here. Remember, there's a negative, so I can go ahead and pull that negative out and then write the u to the negative first down here, like that. So my answer is going to be a y equals negative 1, plug my x plus 3 back in for u, plus c. Sweet. Now these problems do get a little bit harder, but we're just going to stick with those for now and then apply this to a real-world problem. Thanks for watching.